Uh, the last class we talked about, let me just double grab my stuff, implementing objects and using proper use of constructors and objects and static methods inside of something like C#. So that was all kind of good as far as how that goes. And kind of understanding that whole process. I wanted to talk today about inheritance and how we kind of use classes within classes and things like that. Kind of a high level discussion, if you would. But as we're going to go into different types of data structures you might have to convert between, for example, XML and JSON next week or so. A lot of times we're going to be looking at more and more complex types of data. So if we think about it, and this is where if you have a UML model, it becomes really helpful to kind of understand that process. And where UML actually became a real good tool, I think, in helping people develop classes that were showing relationships between not only parent-child type relationships, so where we have a generic class that we are based off of. So we have a person class, and a person has, a name and an age and a birth date and all that type of stuff. And then from there, we can make a student, and a student's going to have a major, and they're going to have an advisor and stuff like that. And then from student, you can have like grad student. Grad student's going to have additional information about graduate school. So, but beyond that, you have a situation where you can take a look and kind of think about, well, what objects, so a class that's instantiated, how would that be used inside of a student? How would I, where could I start grouping things? UML has some concepts you might have heard if you've ever looked at it called ISA and HAZA. So ISA shows that inherited hierarchy type of thing. I am a student. I am therefore a person, and I have that is a relationship. A has a, or has a, if you prefer, relationship is more of I am a student and I have a set of courses that I've taken. And so this might be stored in an array, but each course could link back to a data object. And that data object would have things like what's the course code, who was the instructor, what term was it taught, all those different types of pieces of information that need to be known and dealt with. So when I'm working with something like that, it's very important that I have these types of starting to develop complex relationships. If I go with something like a movie might have a wide variety of people associated with it. Some are going to be actors, some are going to be directors, some are going to be producers. Then you have your different supporting personnel, sound engineers, lighting technicians, makeup, wardrobe, etc. So if I were to pull up like the Internet Movie Database, do I need to know and treat data for a director differently than an actor, or is that kind of interchangeable? How does that work? In both cases, I have a list of movies or TV shows I've worked on. And the Internet Movie Database now also incorporates video games and all types of stuff. So it gives me a good perspective as far as how that works. And then if I look at a movie and I see all the actors, I can click on the actor and then I can see all the movies that they were in. And so we kind of got this multiple hierarchy, if you would, of knowing what belongs to what. And it makes for some interesting um, data prospects of how that information is stored. And we see this time and time again throughout um, all of real life and how we work on that. So um, let's take a step back and let's take a look first at that is a relationship um, as far as developing a hierarchy and things like that. Let me share my screen. I'm just going to bring up the text for this class just so you um, can see that. But one of the three big components of object-oriented programming, there's three things really. If you have object-oriented programming, you have an object-oriented programming language. There's three key components that have to be met. And one of them is this idea of inheritance. And so inheritance is going to be one class based off of another class. I have a generic vehicle class, and a vehicle class is just used to allow one or more people and objects to move from point A to point B. It's very generic, and I can call that an abstract class. I can't actually instantiate it in any way. It doesn't exist. There is no generic vehicle out there. I have to have more. And so I can say, well, I have flying vehicles, and I have road vehicles, and I have water vehicles. And those could even be abstract classes. I can't, create a generic road vehicle. Am I a motorcycle? Am I a car? Am I a truck? Am I like a commercial truck, which is gonna be like an 18-wheeler, or am I a personal truck like a Ford F-150, or am I a box truck? So I can therefore then go in and break additional levels of hierarchy. With each level of hierarchy, if I have my most abstract class at the top and I kind of work my way down, with each new class, I should be providing additional functionality, additional properties and or methods that are going to relate based upon how my data is going to work together and function together. So, for example, the generic vehicle class, I might have properties about a max speed, and that lets me just know, hey, I can travel at this speed. Uh, and I might have some generic information about like weight or something along those lines. But it's very, very generic, very high level. If I then break that down and go to flying vehicles, I might look at having things like a maximum altitude or a minimum speed, what's sometimes referred to as a stall speed. A stalling speed is the slowest speed that a plane can fly without literally not being able to generate enough lift to fly, and it falls out of the air. Um, and at that point, planes act very much like rocks. Their control surfaces don't work. They don't stay up in the air. They're semi-guided rocks. It's not a pleasant experience. If you've ever been on a plane that stalls, especially uh, when it starts to shudder and shake and because it can't get airflow. Um, so you have a situation like that. Um, you could then break that down further and say, okay, I want an unmanned and I want manned vehicles. There's obviously a lot of work being done in unmanned vehicles that fly everything from drone delivery to military reconnaissance jets and prop-driven planes. Under manned flight, you can have powered and unpowered. Things like hot air balloons are not powered; they still fly. Uh, Powered would then now could be broken down, and that could still be an abstract class because you have You still don't have things like, is this, a dirigible style? Is this a private aircraft? Is this prop driven? Is this cargo? Is this passenger? Is this, a lot of different categories? And that's before we get into specific makes and models and instances of that make and model. So, but with each one, I start to add additional levels of information with, uh, if I have an unpowered, I don't care about the number of engines. If I have powered, I might have number of engines and type of engine. And that gives me additional information I can work with. Number of passengers, amount of cargo space, cargo maximum takeoff weight, which gives me load capacity. I can start looking at all these additional factors that become relevant to dealing with a powered aircraft. And I can just keep going piece by piece by piece until I get into, I'm looking specifically for a vehicle that flies, that's manned, that's powered by jets, and that carries passengers. And now I have an instance of a 737 that I can work with. Um, but I might have had to gone through 5 abstract classes, things that I cannot really instantiate because it doesn't give me enough information, but allowed me to create that proper hierarchy to keep adding a little bit of methods. And then when I finally get to that 737 object for that powered jet flight that I'm going to create, um, I've only got to add a few pieces of additional information about it. A lot of that work has been done for me up above. And as I work in a complex environment with lots of other developers potentially, someone's responsible for each of those pieces. Now, there might be, if I only have a team of 2 or 3 people, I might be responsible for that whole hierarchical chain. Um, and then Tyson, you're responsible for the whole watercraft chain. And Kate and Denise, you guys split off and do different parts of land vehicles. And, Kate starts with motorcycles, and Denise is in with passenger cars. And then someone has to break down and do, box trucks and cargo vehicles and 18 wheelers and all that type of fun stuff. So how you split things up becomes very important, depending upon the size of your project, size of your team, all that type of stuff. But the idea is I can have that very generic abstract start and build upon it, and each one gets larger and more complex. And if I'm smart with my hierarchy, I get a good finished object when I'm done. Um, with In theory, each layer adds a minimal level of coding. Now, with an abstract class, I can also have abstract methods, which means that I have a method that is, I have to also write. The abstract method is one that the computer programming language will go in and say, look, you cannot finish this class until you include this method. So if I have a class that has an abstract method, it has to be rewritten and overwritten, um, which is a good thing. We want that ability to say, look, I know this isn't right. I know this isn't complete, but it's going to vary so much. You have to do it, but I know that this is required for my class instance. So therefore, I'm putting it here. You just gotta write the actual implementation of it. So you can have abstract classes. You can have abstract methods. Um, you cannot have an abstract class in a non-abstract, excuse me, almost got that backwards. You cannot have an abstract method that's not in an abstract class. So one of the rules, and every language I'm familiar with has this as one of the rules, is I can have an abstract class and have no abstract methods. It's just you got to extend this and do more with it. But at the same token, if I have a abstract method, my class, which contains that method, must be abstract. So at some point, someone has to write and say, okay, this is it. There is a similar concept. Some languages use, like Java, for example, they use a concept of a final method. And the idea there is they say, look, this method is done. You can't change it. So they will create a final method. If they use the keyword final, there's no change anymore. You're done. They have locked down its functionality. And that's kind of an interesting, weird thing. It says you can't abstract this, you can't build upon this anymore. Like, not sure I like this, but hey, it is what it is. But you do have that final method as well. So it's just kind of an interesting process when you go through that. In the book, text itself, if you see it on the screen, and you can pull it up and look at it elsewhere, you can see how I have a public abstract class of person. This is kind of how Java would be written if you were doing something in Java. And then you have public class student, it extends person. And then you have professor, it also extends person. Administrator extends person. And so what winds up looking right, and I didn't have a UML tool, I probably need to rewrite this as UML, but it winds up kind of looking like this, because then you have grad student, which extends your regular student. So you can think about this in a lot of different ways, a lot of different areas. Many things start with an abstract generic class and then get more and more specific. Sometimes you only need to get one level more specific. Sometimes you've got to get dozens of levels more specific. So it just kind of depends upon your own personal instance of how things are working, what you're doing. So in a case like this, you want to be very careful to avoid the I'll just copy and paste it. A perfect example where I know someone where this ran into, and this was with an early language. It didn't have this idea of inheritance. There was a situation where someone had done some copy and pasting, because they didn't have the idea of inheritance. Well, they had, like, let's say 12 instances of this data type that they had to maintain, and they did the fix. They found out there was an error. They did the fix, and they copy and pasted into 11 of them. The 12th one got mixed for whatever reason. It just got missed. What that meant was then that they had a pretty severe error, and that the whenever that last data type, that 12th one got called, it failed. It just failed outright. It didn't produce consistent results. The worst part was it didn't fail like, oh, and here's an error, and you got the error, and I was not expecting that, but I know where the error came from, and I can tell someone to go and fix it. It failed outright by giving the wrong data. And so in giving the wrong data, you got data back. People assumed that the data was correct. And because they made the assumption that the data was correct and it wasn't, now they're off there making business decisions off of bad data. And so that caused a real problem with that instance and that particular situation. In some cases, that could go unchecked for months or even years. I've heard of cases of stuff like that. Because it works and people go, oh, well, I'm getting an answer, so it must be right, right? Not always. So you always want to be careful, and if you can, use your inheritance for something like that. It's a great way to solve those ideas of, I have this problem, what went forward. Because I can fix a problem back 2 or 3 generations above in a class, and if it solves my problem all the way down the line, I'm golden. that saves me a lot of coding and time and effort and tracking down bugs and having to test each and every instance of them. Let's face it, no one likes testing that much. No one likes going and checking all that code. So this just simplifies that process. Now, one thing you have to be careful of, and this is something that C++ gives you, which is very dangerous, is it gives you the ability to do something called multiple inheritance. So let's go back to our vehicles example. And I've got water vehicles, I got land vehicles, I got airborne vehicles. And I start to build stuff out. I go, ooh, there's this interesting classification called a seaplane. And just for clarification, does anyone ever heard of a seaplane before and know what they are?
No.
Okay. We're just going to take a quick little jaunt into aviation.
Oh, okay. That's what you're talking about.
Yep,
Okay.
this is what I'm talking about. Okay, and so there's a lot of different types of seaplanes out there. Some of them are built with a basis of an existing land-based plane, like this one right here is a Cessna Caravan, and it's got little pontoons so it can land in the water. There's others. This is called a PBY-2. It was used for search and rescue during World War II. My grandfather served on a this is a PBY-2. My grandfather served on a P2BY. There's zero confusion about that. I've talked to historians and they get it wrong. Because I was trying to find examples of that. And it's kind of weird. P2BY. Okay. So this is what a PB2Y looks like instead of a P2BY. Try saying that 3 times fast. And it was based off of a design very similar to what's known as a B-24, except they just basically made a seaplane so it can land on water. It's called a Coronado, and my grandfather flew in those. He was engine mechanic during World War II. Worked on that plane and flew, and it was designed for anti-submarine warfare. So they went on submarine patrols looking for enemy subs in the Pacific Ocean. And so now I'm looking at a plane like this. We'll get this nice big picture. And I say, okay, now I've got an interesting question. Is this a water-based craft or is this an air-based craft? Because whenever it's landed, it's in the water. Whenever it's flying, it's in the air. So I might go, well, if I think about it, I have some of the features of a water-based craft and some of the features of an air-based craft. So can't I inherit from 2 objects? And then I'm going to start thinking about this. And you go, oh, well, that makes a lot of sense. And if I think about biology, I inherit some of the traits from my mother and some of the traits from my father, right? So in real life, biology every day is the combination of 2 separate data sources, if you would, and one object comes out. So I'm going to allow multiple inheritance, and this seems like a really good idea. What's not considered when I take that analogy and I think about it is when I get genetic material from a mother and a father, I get some from the mother, some from the father, and it gets joined into a single unit. When I do it with a class definition, I get 100% from the mother and 100% from the father and join them together. Well, what happens if I have a conflict? I might have two properties that are the same but used differently for different purposes. I might have two methods which are the same name but used differently, or maybe use the same. How do I know? How do I know which one to pick? I don't get any type of collision information to protect me with that. So in a case like this, where I have a situation where this seaplane is getting ready to take off, and it's actually partially out of the water already, am I more like the plane than the watercraft, or am I more like the watercraft as I'm still in the water and not on the air? And how do I make that decision? And I can't dynamically say, well, use this method now, use that method, and that causes some problem. So internally, your programming compiler has to be able to make those decisions, and they may not be the decisions you want to make. This causes some real legitimate issues. And you've got to go through that. And it's just not a pleasant thing to figure out, how do I handle that situation? So when I'm looking at this and I'm going, okay, how am I going to work on this? How am I going to make this better? Java came about approaching it in a slightly different manner. C# uses a similar methodology. And what they do is they say, you know what, instead of inheriting from multiple classes, we're only going to allow you to inherit from a single class. You only have one parent, you get all of its properties, you get all of its methods. And so you might say, but I need to have, he goes, don't worry, we have a method for you. And it's called, we're going to allow you to have something called an interface. And an interface is used all the time. And it says, a perfect example of that is I don't always need this functionality, but a lot of times I do. And whenever I need this functionality, I want to be able to have it available for me. And so I will say, I'm going to use this interface. And the interface defines some methods. And it's kind of like the function prototype in C++. It says what your return type is, says the function name, says the parameters that get passed to it. If it has any exceptions, it defines those exceptions. But it leaves the implementation of that solely up to you. So a perfect example is, have you guys ever used a loop called a for each loop?
Yeah.
Okay. All right. So a for each loop is kind of an interesting thing. Everyone knows how a for loop works. Like in C++, you've got your initializing section, you got your condition section, you got your post loop modifying section. The for each loop just says, for each element in this section over here, well, how does it know how to get a next section? Well, in a lot of cases, what they do is they inherit from an interface a couple of method names. And depending upon what language you're using, there'll be something like iterator will be the interface name, and you'll have, iterable will be the interface name, and you'll have like get next iterator, and you'll have get current iterator, and those are the method names. And so what happens is it says, okay, get the next iterator. For each says, I've got an element in a list, and I'm calling this my list of stuff. It says, okay, in my list of stuff, get the next element. And I have to provide a methodology in order to do that. And if I do that, because I have to do that because if I say I'm using the interface iterable, then anyone who wants to use iterable, like a for each loop, now can do that because it says, oh, I have this interface, I'm iterable. And being iterable means I know methods like get my current iterator, get my next iterator, and those types of things. So that's what the interface lets you do so that you can simplify and not have to have things like adding in subclasses or anything like that. Other place you might see it is if you want to make something seriable. So I'll have like a serialize and a deserialize command. And that's just a process of writing everything out. How do I do that? How do I know when I go from one element to the next for my properties and stuff like that? So there's a lot of things that can be done with the interface as well um, to get the more complex data types if it's necessary. When we start getting into the has a category, um, has a is dealing with your properties. I am defining not who I am in a larger generic sense. I am a seaplane, I am a motorcycle, I am a passenger car. That's a is a. The has a is my properties. I has a number of passengers I can be. I has a maximum towing capacity or a maximum cargo weight or maximum fuel consumption or whatever those properties might be. They're all properties that help describe me specifically in more detail. They don't tell about how I've been created. They're describing me in a specific detail. Um, Now, some of those details are going to be very simple, and I'm going to look at, for example, how many passengers can I carry? That's just a number. I might carry 3 passengers, so I've got a driver and 3 passengers. I might carry 4 passengers or 10 passengers, or if I'm a jet plane, I might carry a couple hundred passengers. Um, that value changes, but it's always a property that's describing myself as an instance. Um, if, on the other hand, I look at something like I'm a student and I want to look at my schedule, okay, what's my class schedule? That's a has a. I have a class schedule of classes I've taken. Those individual elements within a schedule are going to be objects as well. And knowing when to use a complex data type like another object um, is always important and always valuable information. Uh, it's always done on a case-by-case basis. I can't say you'll always use it whenever you have more than X hundred lines of code. That's not necessarily true. Likewise, you might have it if you have, only 30 or 40 lines of code in your class. So you have to look at the code and start to think, okay, with this property, does this property have sub-properties? And if so, then I might need a new data class to store that information and work with it. Of course, one of the big things I always have to ask myself, and this is one of the things we talked about last class, was does this data need to be retained? And if I have a complex amount of data that needs to be retained over a period of time, like a class schedule, then I can have individual classes and courses involved with that I work off of. But if it's just a temporary thing, a fleeting amount of information, it's just stored for literally a line of information, then I don't need it. I can use a static class and static methodology. Perfect example, let me bring this up. This is in C++, but gives you the same basic idea, is I use an anonymous class here, excuse me, anonymous object, where I just call my class constructor, construct a basic class, I call a method for it, and then I get done. It's an anonymous object. It gets destroyed as soon as that line of code is finished. That's where a static method inside of something like C# or Java becomes really helpful. It helps us build functional libraries based upon what we need to accomplish. If we need to store data, then we're not going to use something like this. We're going to use a class that's going to have real relevant information that's going to be used over and over again. Okay? Any questions on the ideas of inheritance interfaces, or the ISA versus HASA methodology with UML references? None? Oh, was that clear? Yay. Hey. All right. I was expecting there to be lots of questions and stuff. I left plenty of time for questions and comments. Okay. So this week we don't have a new assignment that's going to be done. We'll probably have one based off of the XML and JSON data that we're going to be looking at the next week or two, or over the next 2 weeks. We'll probably have one homework and one project assigned with each of those, so just kind of keep that in mind. The homeworks, excuse me, should be pretty short. The projects will be then reading that data in and processing it. Nothing overly complex. I'm trying to keep these projects a little bit shorter because I know there's not as much time to stop and ask questions and stuff like that, although I will be trying to make sure that gets done as well. We'll have class time and we got office hours, stuff like that, to stop and ask as many questions as you all need. That's literally all actually I had for today. Like I said, I was actually expecting more questions. So we got done just over half the class, which I guess is good. So if you guys don't have any other questions, I will let you go. I will try to get the assignments graded this weekend that you guys turned into me, I think on Monday, and try to get caught up with that. It's been a crazy week at my house. Hopefully it's a little saner for you all. But hey, at least we get to go through crazy times together, right? All right. Well, if you guys don't have any questions, you guys are free to go. Enjoy your little bit of extra time to yourself. I'm sure you guys can use it to work on catching up with other things and get our things taken care of and sorted out. If you guys do have questions, I'll stick around. Otherwise, have a good and safe weekend. Don't get too bored staying inside. At least none of you are married and don't have a wife saying, you were saying that when you would have time.
Oh, yeah, nope. Not there yet.
So no, you'll have spouses doing that. So mine's been very good. She's been letting me do all my data conversion stuff to convert these classes online for you guys. So, anyways, all right. Well, if none of you guys have any questions, take care. Otherwise, I'll stay on for a few minutes if you want to wait to admit that you have questions. That's fine too.
Alrighty. Deuces.
Take care.